Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about induction cooktop. It's a hot topic right now, so let's dive deep into it. So what exactly is the problem? Well, problem is that a lot of people and places need LPG, liquefied petroleum gas, for cooking. Now, here's the main deal with that. Most of these places that consume it generally import it, meaning like India, even China, Sri Lanka, basically whole of Asia, so to say. So it creates an issue. So the moment a conflict occurs, people start to look for alternative. Now be mindful, it is logical and normal for countries to have a little bit of reserve, and we do our best to make sure that we can weather some storms. Now again, whenever you're talking about serious population, it's not practical, non even affordable even to think that you can store enough for 6 months or 7 months like that. So the amount is too huge and the financial burden would be too brutal. So generally we do create strategic reserve, but those are only for short up and down. You have to expect the things to get back to normal, otherwise those reserves become like emergency measure, as in like you cut down its expenditure on everything and keep those for absolutely critical things. So fundamentally, whenever a conflict happens, people are like, okay, what else we can do? Thankfully, for cooking gas appliance, induction is one of the toolkits that can take a chunk out of it, meaning it can reduce the consumption. That's always a desirable thing. If war keeps going on, you could have a scenario where it's like the demand becomes too brutal, but if you have an alternative, the reserve that was meant for 2 months can last for 3 months. So there is a problem, and again, if you can permanently shift, that's awesome. So induction here is a solution. So induction heating is basically heating of electrically conductive materials. Does not need to be very conductive, does not need to be very low conductive. It just needs to be conductive and it will work. And the biggest advantage of this is it does not require physical contact. Now, to give you a context, generally whenever you are applying heat to, like, let's just say you have a heater, you apply an object on it, conduction is the main transmission of energy. Here magnetic field is benefit. You can isolate it, meaning you can literally have a coil and just put item below without touching anything, and you can just basically melt metal. And again, we figured out inductive furnace surprisingly early, like early kind of. So the fact that it does not require physical contact, does not even require line of sight, like radiation things require line of sight, conduction things require physical contact. This is like, I do not care. Basically you can put a kiln and put coils outside of it, it will melt things inside it. So it's very good, and it works on all conductive material. Now let that be very clear. Conductive materials have a property. That property affects the frequency. That frequency affects the skin effect. So if you want to heat items, you have to find a right frequency. You can use just brute force, it would be too wasteful. So generally, for example, if you are dealing with steel, you will look into 20 to 25 kilohertz. And if you are trying to deal with aluminum, you can just gonna go to 100 kilohertz. So it is a hard thing to figure out, basically the frequency and all that, but once you know, it just works. You do not have to think about it. So that's how induction works. So how do we achieve it? Well, here's the deal. It's a very high power draw appliance, meaning whenever you are talking about high power draw, certain things like induction motors can have bad power factor, but everything new that we are adding to the market, we are working our ass off to make sure it does not have bad power factor. So high power factor correction is required if you have something noisy. So whatever your design is, especially if you're wanting to sell it, it has to be in such a way that does not create that spiky power draw that happens because of bridge rectification. So whenever you have full bridge rectifier, you generally have a capacitor to smooth it, and that's the worst thing. The rectifier does not do much, but the smoothing capacitor, because again it maintains the voltage, it only allows the when sine wave goes to the peak, it leaches all the energy. So your current waveform is not synced with the sine wave. You create harmonics, bad power factor, it's bad for everybody. So whatever you are doing, you have to make sure this does not create that issue. That's why it does not have a smoothing capacitor. It has a oscillator capacitor and high frequency what you call limiter kind of system, but not smoothing capacitor. So that's how you design the system. It must be good in terms of power factor correction, and we have advanced system that can deal with it, but it's just that why pay for that? So, and again, heating is one of those applications, it does not care. It's not like light where you will see flicker. It's a heat, it does not matter. Even if it has slow PWM, you will not notice. And because we are talking about frequency, all the hardware is very fine-tuned for it, meaning let's say you designed it for 25 or 27 kilohertz, you designed everything for that. The capacitor is rated for that, the switching elements are rated for that, the coil is fine-tuned for that, everything is fine-tuned. So how the heck you control the energy output? Well, you just PWM it, meaning turn it on for 1 second, turn it off for 5 seconds, turn it on for 1 second, turn it off for 5 seconds. So that's how you get what we call control. Basically, that's why you will notice your induction cooktops could have rating like 400 watts, 600 watt, 800 watts, 1600 watts for smaller one. So generally for cost reason, 25 kilohertz is the most favored one. And again, whole industry had worked around it. So 25 is like, we good, we got this. And be mindful, the technology is ancient. Like when we used to patent a draw like this. So it's an ancient technology. The only reason why you and I are talking about it, even though we invented induction for metal industry, is just that semiconductor became cheap enough that this can be something that a civilian can buy. So how the heck you achieve that high frequency? We use resonant tank circuit generally. Basically, it's an oscillator. Now the requirement for the induction coil is that it must get sine wave. It does not like square wave. It does not like what you call PWM, basically 0 to 100 and then 0. It would work, but it would not be great. But if you have like 0 to 100, 100 to minus 200, then to 0, then to like the full sine wave, then it's perfect. So then you will have very good coupling efficiency, meaning energy coming from the grid will directly go into the coil and it will be almost transformed by itself. That's the whole point of resonance again, meaning it's vibrating as it wants to vibrate. You're not tampering with it. You are just like, hey, I'm going to put the capacitor, I'm going to put the inductors in such a way that if I switch the switching elements at the right time, it will by itself switch at 25 kilohertz. So that's how we do this. And again, power factor is very well controlled, because again, if you have a bad power factor item at 4 kilowatts, yeah, it's a bad deal for everybody. Like, God help you if it's like a large apartment building. If few people turn on their induction system at the same time, yeah, kaput. So that's how we achieve it. And how the heck you make the coil, because again, skin effect is a big issue, especially if you're talking about like high frequency, and we are talking about kilohertz. So 25 kilohertz is very high frequency. So we take the normal stranded copper wire and we encapsulate each single strand. It's called Litz wire, Litz, Litz wire. So every single strand is isolated. So skin effect is handled quite well, because if it was shorted, like it was a proper conductor for low basically mains frequency and high current, it will work flawlessly. But for when you are talking about high frequency, that will backfire. Only the skin will heat up, the core will be wasted, and tada. Actually, it would be better if you had a hollow tube for basically induction heater, which again a lot of people do, and in industry where they use hollow pipes and they run water through it to make sure that it's cooled. So all stranded wire allows you to achieve very high frequency without wasting a lot of energy in the coil itself. It has to be this made out of this material. You can't change it. And again, that's why you can't change the frequency also. These are optimized for one frequency. So if Panasonic, let's say, creates a technology, all metal induction top, it would work, but they have to redesign the lid system, this system, everything. And it will cost a lot, because again, capacitors that are used for this oscillation, they have to handle incoming and outgoing energy that is working at kilohertz or hundreds of kilohertz. So that could be brutally expensive. So see, I'm pretty sure that once the patent will expire, it will become a normal thing, but I have a feeling it won't become too normal, because companies want to sell you utensil also, and the electronics cost will be significantly higher. It's not like, okay, a little bit more. No. It would be substantially more to make something stable at 100 kilohertz. So what about the efficiency? Because we all know resistive heating element is 100% efficient. No matter how good the oscillation circuit is, it's not going to touch that. However, the heat in your food is not that efficient, meaning your resistive heater, it can consume 100 kilowatt, it will create 100 kilowatt of heat. But would that 100 kilowatt of heat go inside your food? No, that's the main problem. So where that heat is going? Well, some are radiating backwards, some are being heating the cooktop itself, the surface. And again, that's why it's like, do not touch the surface, it will burn you. So that surface is wasting. And again, a lot of convection. Convection is also leaching a lot of heat away. So even though you can have 100% let's say 1 kilowatt came in, 1 kilowatt converted into heat, how much went into your product? It could be as low as 30%. While induction has much better coupling efficiency because it's magnetic, it does not go through conduction. It's like it can go through air gap. It works surprisingly effectively. And what is heating is the pan itself, the material of the pan itself. And that's why you're supposed to buy induction pots. So it compensates basically how well it couples the energy, electrical energy you consume from the grid into the pot itself, that your food is cooked much faster while consuming less energy if you are directly comparing it to basically resistive heater or gas heater. Gas, again, it's very obvious to see how much heat is wasted. So that's the whole point. That's why people are interested into induction rather than resistive system. You will save significant amount of energy if you are cooking for a family. And how the heck you make the cooktops for it? Well, very simple. You use as thin as possible of basically stainless steel. Stainless steel is strong, robust, and good for induction use, but it's not very conductive. So worst case scenario would be like if you just had a thin steel material, the food will stick to it because wherever the magnetic coil was interfering with it, where it's like heating it up, that place will become too hot, others will not be hot enough, and voila, food got stuck. So what people do nowadays is that you have a stainless steel outer cover, then you have aluminum core, and then you have another stainless steel inner core. The stainless steel inside allows you to deal harsh materials with it. It can survive long enough. The basically backside also allows you to that. So basically aluminum is fully protected. And why you have aluminum in the first place? Well, aluminum is a conductor, meaning the coils, it's interfering on the bottom part, right? Aluminum will leach that heat from here to that top part. So the whole pot heats up far more efficiently if that was not there. So fundamentally, we add this sort of conductor, which again, mind you, I'm just giving you one example. There could be copper, there could be brass, whatever have you. People do experiment with it. There are some companies who are like, we have 7-layer and we have this and all that. Go YOLO on it. But that's the basic one you're generally gonna get. You're gonna have a material that works very good with induction, and then you're gonna have a conductive material that is very good at dissipating that heat into the whole surrounding. So the whole food heats up, not just where the basically food is touching the hottest part. So it reduces your burn risk also. It's very effective, but again, because of the cost reason, you do have to buy these sort of custom pots, otherwise it's not gonna work. Again, let that be very clear. Even after patent expiration, I am pretty certain it's not gonna be cheap. Oh, and again, you can increase the frequency and it can work on stainless steel thin pots also without having that issue where everything just like, gets sticks to it. So what can we expect in the future? Well, world is moving to a new paradigm. Solar is becoming a thing, and it is becoming a thing in all the places that is consuming LPG, like India, Pakistan, Vietnam, and all that jazz. So in those sort of scenario, induction can play a very big role because domestic LPG consumption is a big deal, like big, like multiple container ship, crude oil shipment has to be consumed in order to generate that much. So what about the power consumption? Here's the critical part. While it's power hungry, meaning your induction will consume lot of kilowatt, as in like it needs a fat pipe to work. It does not drink for long, meaning it will turn on, it will heat up your food and turns off. That's the biggest part of it. The kilowatt hour consumption is not high, meaning if you directly compare it to like, let's say 1.5 kilowatt resistive heater, 1.5 kilowatt inductive heater, inductive will allow you to cook food with almost half, or if not, even more. Like you can literally achieve a scenario where it's like, bro, I'm saving 80% of kilowatt hour just by switching from resistive to inductive. It does not apply true if you are comparing heating water in a kettle. Kettle is very perfect, but normal cooktop, there is no competition here. So while it is hungry in terms of power, it's not hungry in the energy, meaning a solar farm can easily deal with this. So, and I'm talking normal household, like my 2 kilowatt can actually deal with a lot of things. And the weak link in that scenario would be my inverter. So you do need powerful inverters to drive it, because again, the power pipe is huge, like 5 to 10 kilowatt, but you do not need massive batteries to, it's like, oh, at night I have to run them, so I need massive battery. No, you don't. So it is useful technology. And again, more and more Indians are getting in a position where they're like, dude, we are just running on solar. At that point in time, having induction saves them money. So it's a really good thing. And what about gas and resistive system? They can be backups, meaning the biggest advantage that we have with LPG cylinders is that you buy you have one cylinder that is your main cooking, you have one backup, and you have backup of that backup. So you good, you got this. And there is no central weakness. It's like, oh, somebody blew up the pipeline or something bad happened. Like, you good, you got this. So we can have that. Again, only difference would be the cylinder would last almost for a year or even years. And it's like, oh, we have to consume that gas. So it's a very interesting, unique gas, because be mindful, it's not about kilowatt, it's about kilowatt hour. That affects your battery size. Kilowatt is not that expensive, not for inverter, not for solar panels. Kilowatt hour is having something that does not consume too much and has better coupling efficiency really is effective. So this was my presentation on basically inductive cooktops and how they are playing a bigger role right now. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.